Good afternoon if you are in Nigeria. Good afternoon if you are in Nigeria. Good afternoon. And of course, if you are outside Nigeria, I will say good day to you, and I welcome you to today's lecture. So far, in this series of lectures on the course titled Statistical Inference 1. So this is the fourth lecture in the series. And so far we've been able to discuss sampling. Specifically, we look at different sampling methods. We've also discussed sampling distribution of a statistic, and we look at two particular statistics, the mean, the sample mean, and the sample proportion. So we've looked at the sampling distribution of sample mean, the sampling distribution of the difference between two means, two sample means. We've also looked at the sampling distribution of proportion, and last week we discussed that the sampling distribution of proportion, as well as the sampling distribution of two proportions or difference of sample proportions. Today, our focus is going to be on estimation and confidence interval. Estimation and confidence interval. So I welcome you to the lecture once again. So in this particular topic, our attention, our focus will center on what we consider as a core aspect of statistical inference, very fundamental. And estimation is very important, particularly if we have unknown population quantity and we need to estimate it. Remember, I said previously that unknown population quantities are referred to as parameters. And if they are not known, they can be estimated. So that is talking about estimation. And how do we estimate the unknown population parameter? We use sample data for the estimation. So in this lecture, we are going to explore both two ways of estimations. So we can have point and interval estimation. We will discuss what those concepts, what they mean. We will also look at how confidence intervals allow us to express the precision and reliability of our estimates. So the objectives for this lecture are listed as you see on the screen. By the end of this lecture, I expect that you will understand the difference between point estimation and interval estimation. Two, I expect that you will also learn the properties of a good estimator. Properties like unbiasedness, consistency, and efficiency. We will be able to explore the concept of confidence intervals and their significance. You will learn how you calculate confidence intervals for means and proportions. Those are two major statistics that we've been focusing on in this course, means and proportions. So how can you calculate confidence intervals for mean? How also can you calculate confidence interval for proportions? And finally, you should be able to discuss the role of margin of error and how sample size and variability affect the margin of error. So these objectives are designed to guide our discussion and practical applications today. But I want to engage you before we move straight to the lecture. So there are I have about 5 pre-lecture multiple choice questions just to stimulate your interest and prepare you for the discussion that will follow. So as usual, you will see the questions and the options. Don't mind if you get it wrong. We will still discuss them in detail. But let's try and see how we will perform. The first question, and I also need you, as usual, write the question number and your option, A, B, C, D. If you have read the lecture textbook ahead, you should be able to answer some of these questions correctly. The first question, what is a point estimate in statistics? A single value used to estimate a population parameter. B, a range of values likely to include a population parameter. C, a method to collect data from the population. And D, a hypothesis about a sample. What are your options? Are people already responding? Yes, maybe Malik, A, Taoka, Ogenebre, B. Seminat, A. Ifedayo, A. Yeah, I still need more responses. We are not going to waste time. Don't wait until I show you the answer before you make up your mind. I can see Mohammed, Free Your Style, Joy Oshuko. It's better you use your real name in this class. Miriam Ibukun, I can see your option A. Good. Tawoka, you seem to be the only odd. I don't know if you want to stick to your option or you want to change your mind, Tawoka. So let's go to the correct answer in this case is actually A. So a point estimate provides a single best guess or best estimate of the population parameter. So, and if you are interested in population parameter or population mean, for instance, then you simply use the sample mean, which will give you a single value as the estimate of the unknown population parameter. So the sample mean X bar is a point estimate of the population mean mu. It's a point estimate because it gives only a single value. Let's go to question 2 quickly. Question 2, which of the following is not a property of a good estimator? We've not discussed it, but if you have read ahead of the class, so A, bias, B, unbiasedness, C, consistency, D, efficiency. Which of the following is not a property of estimator? Even though I've said something close to that in my preamble, so I can see options like A, Malik, Joy, Fedayo. Everybody seem to be going for A. Shemilore going for A. Saminat, Tawoka, this time you are in agreement with us. That's interesting. So, yes, let's move to see the correct answer in this case. The correct answer is actually A. So a good estimator should be unbiased. We will explain what that means. Should be consistent, should be efficient. So when you have these three properties satisfied by an estimator, you say that estimator is a good estimator. So what that means is that the estimator accurately represents the population parameter with very minimal error. So not that there is zero error, but the error is very small. Question 3. You must have had, before now or somewhere or read somewhere that we talk about 90-something% confidence level, so on. So what does a 95% confidence level mean in statistics? A, the sample mean equals the population mean 95% of the time. B, there is a 95% probability the sample contains the population. C, 95% of confidence intervals from repeated samples contain the true population parameter. D, the population parameter changes based on 95% of samples. What are your options? Sikiti P. Timothy, can see B. Joy Oshuko, B. There is no consensus now. I can see some are even not sure what to choose. I know this is, there might not be consensus in this case. So we have people choosing B, A, C. Yeah. Are there more options? Are there more options coming up? So Olaniyan finally, C, Similoluwa, B, Adekola, A. Okay, fine. Let's move on. So the correct answer is C. Not many people actually got it correct. So anytime we say 95% confidence level, it means that if we repeatedly sample, you take the first sample, you compute the confidence interval, you take another sample of the same size from the same population, you compute the confidence interval, you take another sample of the same size from the same population, you compute the confidence interval, and you do that repeatedly. Let's say 100 times. You took different samples, and in each sample, you computed the confidence intervals. Then 95% confidence level means that 95% or 95 out of 100 of those confidence intervals will contain the true population parameter. You take the first sample, you compute the confidence interval from the same population. You took another sample, you compute the confidence interval. Let's say you are able to compute 100 confidence intervals. Then 95% confidence level implies that 95 out of the 100 confidence intervals that you have computed will contain the true population parameter. Don't ever forget that that interpretation. Even many people who are well, very experienced researchers and so on, often misinterpret this particular concept. So if that concept is clear to you, just type yes in the chat menu. Type yes in the chat menu if that interpretation is clear to you. I can see Timothy with with capital yes, Miriam with yes. If it's not clear, just type no, so that we can be a bit interactive. So, okay, Tawuka said no. Okay, because of you, I will just say what I said was that when we say a 95% confidence, level, it simply means that if you compute, you take sample, the first sample from of a given size from a population, and you compute confidence interval. You take another sample from the same size from the same population. You compute the confidence interval, and you repeat this 100 times, which means you will have 100 confidence intervals. A 95% confidence level implies that 95% of the confidence intervals that you have computed will contain the true population, the unknown population parameter. So which means you have only 5% that will not contain the true population parameter. So if your yes now, if your no is now yes, let me know quickly, then we can move on. If your no is now yes, let me know. Okay, so Tawuka, thank you. Maybe okay, Oladapo, thank you. So let's move on. The next question, we are almost finishing this pre-lecture quiz. The width of a confidence interval depends on what? I know we've not discussed it, but this is to prepare you. That is the width of a confidence interval. Since we are talking of confidence interval, is going to be a range of value, and the length is the so the width is the length of that of the range of the values. So A, sample size, variability, and confidence level. B, sample size only. C, confidence level only. D, population size and variability. What's your option? What's your option? Quickly. So for, well, Tawuka is going for A. Manuel going for A. Joy will not go for A. Rather, think she's going for D. Samiat is going for A. Oladapo is going for A. I can see some names that are common. And this class we are many. So I'm taking note of that. That's also part of, so there seems to be consensus except Joy. Joy, will you like to change your mind? Except Joy that opted for D. Joy, will you like to change your mind? Okay, I won't force you, but this is the correct answer. A. A is the correct answer. So the width of a confidence interval is affected by three things. The sample size. So if the sample size is large, it will shrink the width. It will reduce the width. The second is variability. If the estimator is, or if the estimator is, if the variability is large, then it will widen it will increase the width. Another factor is the confidence level. So if we go for higher levels, we've just talked about 95. We could go for 99. So if we go for 99, so higher levels will widen the interval. So it will increase the interval. And you will see this. We'll discuss more as we go into the core of this lecture. Finally, for the multiple choice question, pre-lecture multiple choice question, which of the following best describes the margin of error? Which of the following best describes the margin of error? A, the error in the sample data. B, the range around a point estimate where the true parameter is expected to fall. C, the probability of making a type 1 error. D, the standard deviation of the population. Yes, you might be encountering or you might be seeing some concept for the first time. Fine. So you are gradually getting into the core aspect of the statistical inference. So what are your options? What are your options? Yes, well, interesting. Quite a number of the convergence seem to be around B. So let's look at that quickly. So the correct answer is B. You are wonderful. This is quite... so the margin of error actually is the maximum expected difference between the point estimate and the true population parameter. And that accounts for the sampling variability. So we will talk about that when we get there. So that's the end of the pre-lecture quiz. I hope those things help you a lot. Let's now begin to break down some of the core terminologies that we raised during the quiz, the multiple choice session. So the first one is estimation. So when we talk about, I've always told you that when you have a population, the population may be large. The population, for whatever reason, maybe the population is one that is fragile, can easily be destroyed. So you may not have option than to take samples. So you draw a sample, and then from the sample you estimate the unknown quantity in the population. So we've talked about that. So here, estimation bridges sample data and population parameter. So it is from the sample that you are able to, estimate the unknown quantity in the population. So in between that is the estimation. So estimation would use the sample data and come up with an estimate of the unknown population parameter. So that's why it's a bridge. So it it goes into sample and then use the sample to get a value, or sometimes a range of values to help us to know about the unknown population parameter. So we also talk about the point estimation. So if the value that the estimation provides is a single value, so for instance, you have the population mean, which we represent by mu, and then sample mean, which we represent by x bar. So estimation, we go to the sample and estimate, estimate the mean from the sample, or compute the mean from the sample, and then use it as the estimate for the unknown population value. So if a single value is used, that is, in this case, a single value is used, single value is obtained, then it is point estimate. So we say it's a point estimate because a single value is used to estimate the unknown population parameter. So sample mean is example of a point estimate. We can also talk of other statistics like variance, like standard deviation. So you can also use sample variance to estimate the population variance. So again, a single value will be used in that instance. But when you now say the unknown population value lies between two values, let's say A, B. In other words, it's like you have a straight line and you have A here, you have B here. And you are saying the unknown population parameter lies between these values. Sorry. So between A and B, you are saying the unknown population value lies between A and B. So you are no longer using a single value, but rather you are using a range of values. And you are saying the unknown population value lies within, or is likely to lie within that interval A, B. So in that case, this is this is interval estimation. So in interval estimation, a range of values, the lower value and the upper value are provided, and then we say the value. So if I want to estimate your age, maybe I'm meeting you for the first time and I want to estimate your age. So I can use two estimation methods. One, I can use a single value and simply look at you. When did you finish your primary school? When did you enter secondary school? When did you finish? When did you enter university? What level are you now? So I can use that and estimate and say, oh, you are likely to be 19, you are 21. I'm using a single value to estimate your age that is not known to me. So that's a single point estimation. Alternatively, I can say, okay, given some uh, circumstances and so on, your age will lie between 18 and 21. So 18 is your A, 21 is B, and I say, okay, your age should be in this range. Then I'm talking about uh, interval estimation, which means I'm using two values within which I estimate your age to lie within. I hope that is uh, very clear. So that takes us to, when do we say an estimator is a good estimator? Because there are so many ways to find the um, uh, to find the value of the unknown population uh, quantity. There could be several estimators. It may not be the mean alone. You remember uh, when we were talking of maybe when you were doing descriptive statistics, you talk of measures of central tendency. So you use the mean, you use the median, you use the mode. Uh, the three of them are measures of averages. So, but are they all good estimators? So for any quantity in the population that we want to estimate, we might have several estimation methods, several estimators. So how do we determine which estimator is a good estimator? So here we will look at three properties. The first property says unbiasedness. So for an estimator to be considered good, it should have it should be unbiased. So unbiasedness is a major property. What that says is that the expected value of the estimator equals the true population parameter. You recall that we've talked about this expression. I hope you can still recollect. Equals to mu. So you recall when we call this one the mean of the sampling distribution of sample mean, and we call this one the population mean. So when we say an estimator is unbiased, it simply means the expected value, which is also the same thing as saying the sampling distribution the mean of the sampling distribution of the estimator is equal to the true population parameter. So, and we have shown that previously, that the mean of the sampling distribution of sample mean is equal to the population mean. That is one result that we have established in our previous lecture. And therefore, sample mean, not sample median, not mode. Sample mean is an unbiased estimator of the population mean. Another property is the consistency property. The consistency property is about the sample size, and it says that as the sample size increases, in other words, as you take more and more sample, if the estimator becomes more accurate and converges to the true parameter value, if as you take more sample, you maybe you 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 take sample of 10 and you increase to 20 to 30 and so on. Consistency expects that your estimate gets closer to the unknown population parameter. If that happens, then you say that estimator is consistent. So if you are checking for consistency, you see the behavior of that estimator as more observations are taken. If as you take more observations in your study, the estimate you get gets closer and closer and closer. In other words, if the estimator converges to the true parameter, then you say that estimator is consistent. And finally, we talk about the efficiency. So before we can even talk about the efficiency, that estimator must have passed the requirement of unbiasedness. So we will not even talk about the efficiency if that estimator has not been confirmed to be unbiased. So uh, for efficiency, you now go to the family of unbiased estimators. You now look at only estimators that are unbiased, and you now look for the one with the smallest variance. So in that community, in that uh, group of unbiased estimators, the one that has the smallest variance is said to be more efficient. So efficiency is tied to the variance of the unbiased estimator uh, to uh, to unbiased estimators. So these are the three major properties. And for an estimator to be a good estimator, these three properties must be satisfied. And if the three are satisfied, then that guarantees know that the estimator or the estimate produced by the estimator is reliable and accurate as far as statistical inference is concerned. Uh, there are other properties as you move, advance in your statistical knowledge. You get to know about other properties uh, that are considered, when looking for a good estimator. But for now, unbiasedness is about whether the mean of the sampling distribution of the statistic is equal to the unknown population parameter. Consistency is about the behavior of the estimator as you collect more observations. And that's why when you are doing studies, you must always be careful of your sample size. You must always suspect your sample size. Small sample sizes may not give you a consistent estimate. So if you have to now look at how your uh, estimator behaves as you increase your sample size. It's expected that as you increase your sample size, you are getting closer to the fact. For instance, an incident happened and you now want to establish the truth. Uh, and you ask only one witness what happened. One witness will tell you uh, the aspect of the story that he or she witnessed. And then if you take more, witnesses, they provide different angles of the story. And that helps you to be able to know the fact of the story. But if you are satisfied with just few witnesses providing you information, their witnesses may not be consistent, may not be reliable. So efficiency is about the variability, but it's also tied to only those estimators that are unbiased. So if an estimator is biased already, I mean, it's not even considered as far as efficiency is concerned. So efficiency is only for the unbiased estimators. So among the unbiased estimators, the one with the least, with the smallest variance is the unbiased, uh, is the efficient estimator. So that takes us to how do we now compute confidence uh, interval. So we've talked about point, uh, and we now need to compute confidence interval. So by definition, confidence interval provides a range of values uh, where the population parameter is likely to lie. So it's usually that you have, you know, uh, the 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 minimum value or the lower limit, and then you also have the upper limit. So maybe A, maybe B. So you could have the lower limit, and then so your estimate is here. So you have the estimate here. So you have the estimate here. For instance, if this is the X bar, this is the X bar, then you are saying the unknown population parameter or the unknown population mean is between the lower and the upper values, between the minimum and the maximum values. But this is your estimate, the point estimate. So for you to even compute confidence interval, the starting point is for you to compute the point estimate. So in the case of population mean, the point estimate is the sample mean. The point estimate is the sample mean. In the case of population proportion, then the point estimate is the sample proportion. So when you get the sample proportion, you will now need to determine what will be the lower value, and you now need to determine what will be the upper value. So the width that we talked about before is provided by the formula. This is the margin of error. So the margin of error on this side will be computed and added to the estimate to be able to get the upper limit, and subtracted from the estimate to be able to get the lower limit. So that's how it is done. So the starting point is get the point estimate and then compute the margin of error. And the margin of error is added to the point estimate to obtain the upper bound, the upper limit. And the margin of error is deducted from the point estimate to be able to get the lower limit. And so you will now get the range of values, which is what we call the confidence interval. So which is denoted as CI. So CI is point estimate plus or minus the margin of error, MOE. So which then means that the lower limit is point estimate minus margin of error, and the upper limit is point estimate plus margin of error. So if, for instance, the lower limit is 4 and the upper limit is 6, so anybody here should be able to tell me what the point estimate is. So it means I've added 1 to this. I've also removed 1 from this. So how do we interpret? And we have discussed that before, that the interpretation of the confidence interval. For instance, if you have a 95% confidence interval, let's say you are interested in income. For purpose of discussion, let's say you have this Wow. Sorry. Good. Okay. Let's say for purpose of discussion, you have, we are talking about mean, and this is lower limit is 48,000 and the upper limit is 52,000. So which then means that we are saying that the unknown population, the mean, the population, uh, the mean of the income of the population lies between 48,000 and 52,000. So the two values represent the range of values that we expect the population or uh, the average income of the population to lie. And so if this is computed based on 95% confidence interval, I will still talk more about that. It simply means that we are 95% confident that the true mean income lies within 48,000 and 52,000. So, and going by the interpretation that I earlier mentioned, it means if we take a sample from this population, sample of a given size from this population, and we compute the confidence interval of the sample of the mean from this sample. We take the second sample of the same size from this same population, obtain another confidence interval, which might be different from this because the sample values will vary. So if we do 100 samples, which will lead to 100 confidence intervals, then 95% confidence interval implies that 95% of the confidence intervals that we have produced will contain the true population, the average income of the population. So that is how the 95% confidence interval is interpreted. So let's spend a little time to discuss the margin of error. We know margin of error is very, very important here. Very, very important here. And so how do we compute it? For point estimate, we really don't have problem with that. If it's mean, we can use the sample mean. If it's proportion, we can use the sample proportion. We know the formula already. Even if it's variance, standard deviation, we already know the corresponding sample estimate or estimator. So we can use that to obtain the point estimate. But how do we compute the margin of error? First, by definition, the margin of error is the maximum expected difference between the point estimate and the true parameter value. You've seen that is the maximum difference. If you add to it, that will give you the upper value. If you subtract that value, that margin of error from the estimate, that will give you also the lower value. So don't ever forget that the margin of error is actually the maximum expected difference between the point estimate and the true parameter value. So, what are the factors affecting this? In other words, before you can even compute the margin of error, you need the sample size, you need the standard deviation. The standard deviation, that's the population standard deviation. And 3, you need the confidence level. So all of this, the confidence level will be determined by the researcher. You are not bringing it from heaven. So the researcher is the one that will say, okay, I want 90% confidence level. I want to be 90% confident that my true, the true population quantity that I'm interested in, will lie between the range of values that I get. If you are okay with 95, you choose 95. If you are okay with 99, you choose 99. So higher confidence, people can choose the researcher. The point here is that the researcher chooses the confidence level. What about the sample size? Yes, of course, that's the amount of information or observations available to you. Sometimes that can depend on your budget, because if you have enough budget, you can keep on taking more samples. And if possible, you even use the entire population. But where the population is rich, you don't even need to talk about point estimate again. So you simply compute the population parameter. But in most cases, you will not be able to use the entire population. So if your budget is quite handsome, you can take more and more sample. What of the standard deviation of the population? Usually it's not known, and so you have to estimate it. But you may take advantage of previous studies that have been done before, maybe published, and they already have idea or suggested what the population standard deviation is. You can leverage on that. You can use that, But for now, how do these 3 quantities, how do they affect the margin of error? So for sample size, if you take enough sample size, the margin of error will reduce. It will be very small. So in other words, it will make the width to shrink. For standard deviation, which measures the variability in the population, higher variability will increase the margin of error. So which means it will expand the width. But if the standard deviation is more, it will close the width. Finally, since the researcher determines the confidence level, if you go for higher confidence level, again, that will increase your margin of error. That will increase your margin of error. So it's always good now to look back at this formula. Always look at this formula. If you increase your margin of error, then your confidence interval, of course, will become wider. If you reduce your margin of error, then your confidence interval becomes narrower. Which one is better? Make your confidence interval narrower, make your confidence interval wider. That's a question I leave to you, but we will answer it before the. Which one will you prefer? A narrower confidence interval or a very wide confidence interval? What does it tell about reliability of your estimate? And what does it tell about the efficient or the the reliability of your estimate, so to say, you know. So don't forget these three factors that often affect your confidence interval. So let's take examples. We have confidence interval for a population mean. So the margin of error is computed using this expression. You know how to obtain the estimate, the population, the sample mean is used to estimate the population mean. So X bar is the estimate. But this expression Z, which is the standard score, and you remember in the last lecture we talked about the standard score. I know you can still remember how we compute the standard, you get the standard score, or the Z score, not the standard score, the Z score. So the Z score in this case is going to be obtained from, it will be based on the confidence level that we choose. It will be based on the confidence level that we choose. And if the confidence level is, there is a table here which I will quickly show. This table helps us to determine the confidence level and the Z scores associated with that. You can always get these values also from your statistical table. So if your confidence level is 90%, if the researcher chooses confidence level to be 90%, it means in that formula, Z score will be 1.645. The significance level is, I will still talk about that later, but is the, for now, since we said confidence level is the level of confidence that you have. So I would define the significance level for now as the level of doubt that you are willing to entertain. So if you have 90% confidence, or you are interested in confidence interval, 90% confidence interval, then it means you are willing to take 10% doubt of the estimate, and that's fine. So the confidence level is the complement of the significance level. So if the confidence level is 90%, the significance level will be 10%, which is 0.1. No. If the confidence level is 95%, then the significance level will of course be 5%. If the confidence level is 99%, then the significance level, that is the level of doubt that you want to admit or tolerate, will be 1%. So, and then you have the corresponding Z score. So If the confidence level is 90%, then the level of doubt is 10%, 0.1, and the Z-score is 1.645. If the confidence level is 95%, then it means you are ready to take 5%, you can accommodate 5% level of doubt. And then the Z-score is 1.96. Finally, 99% confidence level translates to 1% significance level, and Z-score is 2.576. You will notice here that as your confidence level increases, your Z-score actually increases. As your confidence level increases, as you can see, as it increases, actually, maybe I should use the, so as the confidence level increases, you can also see that your Z level increases. So let's now go back to the computation here that we are talking about. So here we've seen how we can compute our Z. So for you to compute your Z, you need to know your confidence level. So we are giving our confidence level here to be 95%. And once it's 95%, your mind should quickly go to the Z-score, score, which in this case is going to be 1.96. So the standard deviation is the population standard deviation. So that will be given, and if it is not given, if you have the data, you have to estimate it using the sample standard deviation. We will still talk more about that later. The other thing you need is the sample size. Of course, that is trivial. It's easy to know your sample size, so you know how many samples that you have taken. So with all that, you can now substitute the sample mean in this case. So to compute the margin of error, yeah, then you need Z. Z is 1.96 because the confidence level is 95. So Z is 1.96 times the standard deviation is 10. So 10 divided by square root, sample size is 100. So the square root is 100, square root of 100. So that gives you 1.96. And therefore, confidence interval by the previous expression is the estimate of the population mean, which is obtained using the sample mean, 50, plus the margin of error, 1.96. So plus or minus. So if I remove 1.96 from 50, that gives 48.04. If I add it, that gives this. So this gives you, this interval is what we will now call 95% confidence interval for the mean, for the population mean. So that, I hope, is very clear. The same approach if we are interested in computing confidence interval for a population proportion. So we're already familiar that you get your estimates by using the sample, the formula for sample proportion. And you get your set score depending on whether your level of confidence is 90, 95, 99. I know somebody will ask me, can it be 92? Can it be 96? Can it? Yes, it can be. It can be. But the common ones are 90, 95, 99. So, but nothing stops you, and you just go to your statistical table to be able to get the Z score. So multiply by the square root of the product of the proportion of success and the proportion of failure divided by the sample size. So our sample proportion is 0.6, sample size 100, confidence level 95%. Z, therefore our Z is 1.96. And then you can get the margin of error using this expression, 1.96 times 0.6 multiplied by 1 minus p, 0.4. This gives you 0.096. And confidence interval is the estimate plus or minus the margin of error. So if I remove 0.096 from 0.6, that gives me the lower limit. If I add, that gives me the upper limit. So this is the 95% confidence interval for a population, for the population proportion. 95% confidence interval for the population proportion. So we can see now anybody in this class should be able to compute confidence interval for mean, confidence interval for proportion. I've already explained this, so don't forget these values. So uh, so uh, you have confidence interval. They are widely used in real world scenarios. And some of them you can include if you are estimating average test score in a school, you are estimating average income. So we are looking at practical applications now. Average income of a city's residents. I can ask you, for instance, what is the average age of being a graduate at the University of Ibadan? What is the average age of households in your city? What is the average income of households in your uh, community? So we can apply this thing to different situations in your field of study, economics, other experimental sciences, social sciences. Issues arise where you need to estimate population that you don't know, or the values are not, the quantities of the population are not known. So the same for population proportion. You can determine percentage of people who prefer a particular product. You can determine the percentage of voters who favor a particular candidate. You can also determine confidence interval. You can say 95%, you can determine the 95% confidence interval of the voters in Oyo State that favor a particular political party, and so on like that. In your hall of residence, when you are uh, preparing for election of your student, uh, the president of the student union, you can estimate the proportion of students in favor of a particular contestant. You can also compute the confidence interval for the proportion. So they have, all these things have applications in different fields. And you can also do comparative studies. When you are doing comparative studies, you can easily compare the means, you can compare proportions of two groups, and you can do the comparison using confidence intervals. Uh, Maybe in subsequent lectures, and even in when you take more advanced courses, you begin to appreciate the beauty of this discussion. So you can compare means, you can compare means or proportions of groups, and see uh, which, whether groups are different or whether they are not different. You know, you can compare teaching methods. You can compare the number of. You can compare proportions of uh, those in favor, those not in favor, and things like that. So at this point, we we are almost through. Uh, Finally, the takeaways, the key takeaways uh, for this discussion are summarized as follow. We've talked about estimation, and we can see that estimation helps us to infer population parameters from a sample. So I have shown you the role of estimation as a bridge between sample data and the population data. You use the sample data to estimate the population quantity. We have also learned about confidence intervals as range of values within which population parameter is expected to lie. And it helps us, it offers more reliability than point estimate. So you feel more confident if somebody is able to say uh, tomorrow that uh, uh, the the that a particular the average, that the average, let me say that exchange rate will lie between uh, so value and so value. That's using interval estimate than somebody who uses a point estimate and say, okay, exchange rate will be exactly this. You know, uh, using the interval, it's easier to even, uh, it's more reliable than when you use a single value. So the margin of error, we've seen that is, it highlights the precision of our estimate and is seriously affected by sample size, by the variability of the population, and also by the confidence level. And we've seen that larger sample sizes uh, and lower variability will lead to a narrower confidence interval. What that means is that if you have large enough sample size, and the variability of the population is very small, then you have a more precise confidence intervals. So understanding this concept is critical for making uh, accurate and meaningful inferences in research and practice. So thank you very much. This is the end of this part. But as usual, we also have our post lecture uh, quiz. So, but let me see if there are questions. If there are questions, uh, good afternoon, sir. You are okay. Thank you. That's a good compliment. But I hope you have learned something. Uh, yes. Good afternoon. You go to okay. So if you have question, you can post your question. But let's go quickly to. I've not seen any question on the chat. Uh, but let's go to the first post lecture uh, question. What is the primary goal of estimation in statistics? What is the primary goal of estimation in statistics? A, to describe sample data only. B, to infer population parameters using sample data. C, to find the exact value of a population parameter. D, to ensure no sampling error occurs. What are your choices? Quickly, you have just a minute for that. You have just a minute for that. Yes, I can see the usual people. B, 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 B. What is the primary goal of estimation is that? Yeah, this class is a brilliant one. I think everybody here seems to be brilliant, but some are waiting for others to respond. Okay, uh, to save time, I think the consensus around B is correct. Estimation uses sample data to make inferences about unknown population parameters. That's a good one. Which of the following is a property of a good estimator? You don't even need to blink your eyes to choose the correct one. Which of the following is a property of a good estimator? bias, consistency, randomness, variability. What are your choices? What are your choices? 2B, yeah, yeah. Some people are very active in this class, and some are dormant. I can see people responding, even responding correctly. That's quite uh, delightful. Okay, so what's the correct answer? B, consistency ensures that the estimator converges. Oh, is that, sorry, the correct answer, yes, the correct answer is consistency. Yes, consistency ensures that the estimator converges to the true parameter value as the sample size increases. Uh, Bias is not a good, it's not a good property. Rather, unbiasedness is a property of interest. Consistency is a property of interest. Uh, Randomness is not, in this case, a property of estimator, but is very fundamental when you are drawing your sample. So, uh, and then of course, what's the what's the fourth one? Variability, yes. Variability is captured in the efficiency, because that's where we talk about the variance, of the unbiased estimators. So, question 3. The margin of error in a confidence interval is affected by sample size and standard deviation, A. B, sample size and population size. C, sample size only. D, population mean and population proportion. What are your options? What are your options? The margin of error in a confidence interval is affected by, yeah, everybody seems to be going for A. Yeah, yeah. Okay, the class is a brilliant one. No time to waste. No time to waste. A is the correct. The margin of error depends on the sample size and, of course, the standard deviation of the data. Of course, one thing is not included in the options, and that is the level of confidence. Remember, level of confidence is also very important. So question 4, if the confidence level increases, if the confidence level increases, this time we are talking about the confidence level, what happens to the confidence interval? If, for instance, I increase my confidence level from 90 to 95, from 95 to 99, what will happen to my confidence interval? Will it become narrower? Will it become wider? Will it remain unchanged? Will it depend on the sample size? If I increase the confidence interval, if I increase the confidence interval. Yes, what are your options? What are your options? What are your options? I know there might be no consensus here. Fedayo is choosing B. Others, Malik has chosen B. Wonola A. Abraham Oladapo A. Wuraola A. Mike Prishi A. Yes, 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 yes. I need more response. Emmanuel has joined the group of bees. Emmanuel Adekola has joined the group of bees. Yes, who else? Emmanuel again. B, insisting on B, insisting on B. You need to think very well. You need to think very well. To save time, others are not responding maybe because they are not sure. David finally said B. Okay, so what's the correct answer? The correct answer is B. Higher confidence level require greater uncertainty, leading to wider confidence interval. So B is the correct. So if you increase your level of your confidence level, then you are actually making your confidence interval to expand. You are making it to expand. Because remember, that will increase, you are multiplying the Z score that you get as a result of your choice of confidence level. You are multiplying it with a constant. And so, well, I mean, it's a constant that you are. So as you increase, that Z score also increases. You know, remember the table I showed you when it's 90% is, when it is 95%, 1.96, when it's 99%, 2 point something like, and so on like that. So it increases, and if the Z score increases, it widens your confidence interval. Yes, question 5. Which formula is used to calculate the confidence interval for a population mean when the population standard deviation is known? Only the brilliant one would get this. A, B, C. Which one is the correct formula? Which one is the correct formula? We are now in question 5. Nobody has responded. Question 5. Question 5. The brilliant ones are responding. Awoka, I think you will get a prize someday. Yes. Oladapo, the usual people are responding. Malik, Mike, Wonola. You better type the number and the option. Joy B. Okay, so that's interesting. I think it shouldn't be a problem. The correct answer is B. For a population mean, the margin of error is calculated as Z multiplied by the standard deviation divided by the square root of n. Question 6. A 95% confidence interval means what? A, the interval contains the sample size in 95% of samples. B, the interval contains the population mean in 95% of samples. C, the population parameter falls within the interval with 95% certainty. D, the sample mean equals the population mean with 95% accuracy. Yes, what are your options? Malik has come out first. A. You remember we treated something like this in the pre-lecture quiz, if you remember, and we later explain it. So I still expect more responses. Yeah, people are getting Some are, there seem to be a controversy now. Some are going for A, some are going for B, some Blessing is going for C. Well, Joy goes for B, Ifedayo for B, Malik for B. Okay, David Mfonobong. Mfonobong. Okay, let's go to the answer. The correct answer is C, actually. No, so a 95% confidence interval implies that 95% of the samples, in 95% of the samples, the interval will contain the true population parameter. No, the population falls within the interval with 95% certainty. C is the correct answer. So, question 7, we have 3 more to go. What is the standard score of a 90% confidence level? What is the Z-score of a 99? Sorry. What is the Z-score of a 99% confidence level? Of a 99, what is the Z-score? What is the Z-score?